This is polynomial.
We need to use the
partial
fractions.
So x plus 2 over
x plus 2
x
over
squared.
x plus.
We will do it like we will factorize this.
Yes, factorize. So it would be 3 and 2, right?
X squared, but we cannot we cannot factorize this. To factorize this, we need to do like this. X equals minus b over 2a plus or minus square root b squared minus 4ac. A is 1 and b is 4 and c is 5. This is quadratic formula.
I know, yes. We call it determinant. I don't know.
This part is a determinant. This part.
Yes.
Is determinant. So now minus b, which is minus 4
plus
divided 2 power 1 plus or minus square root b squared 16 minus 4. A is 1. What is this? C is 5.
Yes.
Minus 4 plus or minus square root.
Square root
16 minus 20.
It's just
divided 2. Minus 4 plus or minus square root. This is negative
4. So it would be negative 4.
Negative 4. So now we don't have
roots in negative.
This is undefined or not real number. I don't know, not real number. But we can make it like this, minus 4 plus or minus 2i divided 2. So we have two solutions, minus 2 plus 2, minus 2 plus 1i, and minus 2 minus 1i, because divided 2. Divided 2 equals 1, divided 2 equals 2, divided 2 equals 1. I don't know how, can we work with this or what? X squared plus 4x plus 5. Type. Let's make it by substitution. Substitution. Let t equals x squared plus 4x plus 5. dt equals 2x plus 4, right?
Yes.
Dx.
Dx. So dx.
So we will take common factor 2. This is x plus 2 dx. This is dt. So dx
can we find dx
equals dt
over
divided
2
to x
plus 2.
So at x equals 0, t equals 0 squared plus 4 times 0 plus 5.
Oh, so it's equals
t
5.
Equals 5. At x equals 1.
It's 1 squared plus 4 plus 5. It's equals 10.
10.
So here we Ustaz, for example, how can we do in this situation? Like we have in numerator x plus 2, but we also have dt equals 2x plus 2. How can we write x plus 2?
We'll do it now. So this is from 5 to 10. This is t. And dx is dt divided what? Divided
2x plus 2.
X plus 2. And we have here x plus 2.
Yes.
So by simplifying x plus 2 with this x plus 2.
So we have the t over 2t,
from
right?
5 to 10, yes. dt over t, and we have here 1 over 2.
Or like this,
So
yes.
this is 1 over 2.
Yes, dt over t
Len t.
Yes.
From 5 to 10.
Yes.
So this is 1 over 2.
1 over 2 c, which equals x squared plus 4 plus 5?
No. Len 10 minus len 5.
Really?
Yes. 1 over 2. Len 10 divided len 5.
Ustaz,
Yes.
just a moment. Can you explain why we don't use t when we do len? Like why don't we write t as a x squared plus 4x plus 5 as we did it before in integration?
We don't need to, because we
have limits.
Yes. What?
Because of the limits, because we have limits, that's why we don't need to put instead of t, like what we used t as a substitution, yes?
Yes, we just need to solve the problem. So this is the solution. We substituted t equals this, and we changed the limit. So the new limit will give us the solution.
Okay.
This is our solution. Here we will revise here. How did he solve it? This is which file?
I think it's original derivative, the first one we studied. Not the last one, not definite integrals.
This is not definite?
No, it's not. It's even using derivative for approximation stuff. It's using derivative for
using derivatives for approximations.
Yes. Yes, definite integrals and errors. It's the second one. Yes, this one.
This is substitution. He is explaining the substitution. And now he is saying that the substitution we will work from alpha to beta, just alpha. He did this. You see here, this is t power 1/2 over what? Over 1/2. So he just put The root t, يعني he just worked with t. He didn't go back to x. This is 2/3 root t for 25. So this is 2/3 root 25 minus root 4. This is 2/3. Root 25 is 5 minus root 4 is 2. 2/3, 3. This is 2. Do you see?
Yeah.
He didn't go back to x and put root x instead of t substituted again 3x. No, he just worked with t. Hello?
Yes, I'm here. I've heard that.
Fine. Now, this one. From 1 to e, integration from 1 to e ln x root ln x divided x dx. So, what's the integration of ln x?
Integration in x, it's
Derivative, I'm sorry, derivative of ln x.
1/x.
So we will substitute by substitution. Ln x equals t.
Yes.
So dt equals 1/x
dx.
X.
And should we find the x or we don't need?
We find t at x equals 1. T equals ln 1, right? Ln x, which is ln 1. What is
Yes.
ln 1?
It's ln 1, it's 1/x.
Ln 1 is 0, I think. 0. And at x equals e. So t equals ln e.
And
what is ln e? Ln e. Again, it is 1. So these are the new limits. Okay?
Yes.
Fine. Now, the integration of from 1 to e ln x root ln x divided x dx is integration from 0 to 1. Ln x is what? Is t.
It's t, yes.
Multiply root t divided x dx. So dx over x is dt, just dt. You can see that because this is dx over x. So this is dx over x is dt.
Yes.
So this is integration from 0 to 1. T power 3 over 2, because this is t power 1 and this is t power 1 half. T power 1 multiply t power 1 half is t power 3 over 2, right?
Yes, right.
What's the integration of t power 3 over 2? T power, we add 1, so yes, this is t power 5 over 2.
5 over 2.
Divided 5, multiply 2. From 0 to 1. So 2 over 5 multiply 1 multiply 5 over 2 minus 0 power 5 over 2. So this is 2 over 5 multiply 1, which is 2 over 5. This is the solution. Okay?
Yes. Okay.
Now, integration, disintegration.
Yes.
How we do it?
We do it, I think, by substitution too.
No, by parts.
Yes. Okay.
This is by parts. And by parts, we do v of x equals x, and v dash x is 1,
1. Yes.
and u
X
dash x is e power x, ux is e power x. Right?
Yes. Yes.
Integration 0 to 1, x e power x dx is integration of s
by v, which means e power x multiply x minus integration ex multiply 1, which means u dash x multiply no, ux multiply v dash x, which means x